Welcome back to this journey on developing a Pong clone. Currently we're at the stage where we have two rectangles resembling the two players, and both of them can move, which is quite a good start, and their movements are blocked at the borders. So that's what we did the last two episodes, and in this episode I would like to code the movement of the ball. And to do that, I think we should be able to reuse the move rectangle method that we have right here. And while the event loop is running, regardless of the event, we should move the ball. Let's just say move. Do we need to provide a wrapper method? We have a move player, and the move player does something. It blocks the movement of the player and then calls move rectangle. Should we do a move ball as well? I don't know. Let's just move the ball and see later if we need to abstract it. I like to keep things simple, so let's do a move ball here. And let's just well, how is the ball supposed to move? Initially, there should be an initial speed, I would say. So before we start the event loop, we initialize the ball and then we give the ball a speed. So let's initialize a speed here, ball speed, and that is speed. And which X and Y speed do we give it? Actually, I would like to give it a speed that somehow correlates to the movement speed static integer we introduced up here. But I think for before we do that, we just should keep things simple. So the movement speed defines how fast things are supposed to move, including the players and the ball. And the ball speed should be a speed vector that points in any direction, and the direction should be random at the beginning. And to do that, well, it should be random, but it should be normalized to the speed vectors. So it should be speed 10, so whatever is defined here, but pointing in any direction. How do we do with that? I left university a couple of years ago, so if you asked me that back then, I would immediately know how to normalize a speed vector, but I have to give it some thought. What's going wrong? Okay, so we are in this line right here. Set number, we're in line 46, initializing the ball speed. Let's just keep it very simple and give it a speed of 10 in X direction and 0 in Y direction. And that is the ball speed. And then we can move the ball and say move rect. And then we provide the surface, the rectangle of the ball. And then the direction. We don't have to provide the speed. No, that's just for the move player method. I was thinking about the direction -1 and 1, but that applies only to the move player method. Because here we provide a direction, and then from the direction a new speed is derived. But for pure movement of a rectangle, we should be able to provide a speed vector directly. So we can pass the ball speed here. Does it need to be a pointer? Yes, it needs to be a pointer. Does that even make sense? I don't know. But let's just pass the pointer. I mean, a pointer doesn't really make sense much because the ball speed is not going to be modified. At least not inside the move rectangle method. Well, but never mind. We're moving the ball now. And I think we can compile this and we should see the ball moving off the screen. But something is still wrong. There's an error in line 48 according to the error message, which is this line up here. This line. Yeah, and that's because I missed the semicolon up here. And now the compilation works. And you saw the ball firing. And it removes the border again. How annoying is that? So let me just show you again. The ball starts at the middle of the screen, at the middle of the window. And yeah, because of the way we implemented the move method, this part of the border is erased. Yeah, I think that has something to do with we don't use a renderer and we move rectangles by painting the old coordinates black, or the old position of the rectangle, and then painting in white the new position of the rectangle. So when the ball crosses the border, it will paint the border black. That's why. Anyway, so that means we have to redraw the border after the movement of the ball. Redraw border. And now the ball is moving away and the border is still intact. And now, of course, I would like to see the ball, changing directions when the ball hits the left hand or right hand, imaginary border. So I'm thinking of the Pong game as let me just pull up Paint. I think this would be a nice example. Or maybe, come on, snipping tool. Snip this. Oh, I can show it here as well. So I'm thinking of this game as taking place in the following region. Can we draw something in here? Yes, a shape. So the game takes place here in this region. I hope you can see that. And the ball should only move from the right-hand side of player 1 until the left-hand side of player 2. The ball will never cross this, or the ball will never exit this surface. It should bounce from left to right and from right to left and never cross this border. So we have to define the inner border here. And to do that, we can do, we could, how do we do that? I think we can just hard code it for now in a new method called move ball. So move ball. On the surface, we provide as input the ball, and do we provide the ball's speed? We should provide also player 1 and player 2, so that the method has access to the positions of those players, of those rectangles, in order to detect when the ball is being hit and when it's not hit. So we are going to pass ball player 1, player 2 for the collision detection. Anything else that we need in this method? The ball has a speed, but do we need to pass it from outside into the move ball method? I don't think so. I think we can dynamically generate it inside the move ball method. So then let's create a move ball method. Void move ball. Practically we have a very similar input as the move player method signature, so I will just reuse that. Move ball, STL surface, then we receive 3 rectangles actually, the ball, then player 1, so this is the ball, then player 1, STL rectangle player 2, and that's it. And in here what do we do here? So now it gets really interesting because that's the key game dynamic here. So the ball has a current position and we need to check if the ball hits a border. So, because if the ball hits a border, then we need to define a new speed for the ball. But the speed is not associated with the ball, so it might be might make sense to define a new structure that is the ball. Let's define the ball, and the ball has a speed Does it need to be a pointer? I don't know. I don't think it needs to be a pointer. Why would I need a pointer here? And so we will use a speed. The ball has a speed and, of course, it consists also of a rectangle that is being drawn. Does this need to be a pointer? Yes, maybe because we're referencing the same rectangle over and over again. Ball. Okay, that is the ball. Or should we keep it more simple without that structure here? Maybe we can just pass in a speed that we define somewhere, and it should be a pointer, so we can override the speed inside that method. Ball speed. Let's just try it like that. We can change it anytime in the future anyways, if we need to. Okay, we move the ball by checking first. Let's just do stupid simple checks. If the ball is a rectangle, a pointer to rectangle, so we use the arrow operator. If ball.x is smaller than the left border. And what is the left border? The left, and I'm talking of this inner border that we discussed, and the left border is defined by the right hand, or by the, actually it is a combination of the x coordinate of player 1 plus player 1's width. In this case, it's 40 plus 40, so the left-hand border is 80. I will define a static variable for that. Left inner border. And that is 80. So we can check if x is smaller than left inner border. If so, then we need to reverse the speed. So we access ball. So this means the ball hit the left border. This means we need to change the x component of the ball speed. Ball speed x Is there a better way to do that than this? Just reverse it. I'll just leave it like that. That should be fine. So if the ball hits the left inner border, then we will reverse that speed. I will also use that left inner border variable here. So this is the x coordinate and the y coordinate of the rectangle. Then this is the width and this is the height. Where does the left inner border come into play here? It should be this left inner border and subtracted by the player width. And then we supply the y coordinate. That is just a random value, that is not important. Well, the rectangle can start at any offset, at any y offset within the border, so that's not something we have to care about now. Then the next one is the width. So that is the player width. And then the next one is the player height. So we can define these as static variables as well. Player width is 40 and player height is, we had it at 200. And this, let's see if that compiles. No. Why doesn't it compile? Too few arguments to function move ball. Yeah, of course. We did not call the function properly yet. We have to supply a speed here. And I think we already defined a ball speed earlier, so we can use that. Where's the ball speed? It's here. Yeah, great. So that should compile now. Let's see. Okay, the players can still move and wait. Yeah, I was using the wrong key. The players can still move, but the ball does not move because in the move ball method, we did not update the ball's position. We just introduced left inner border handling and made sure that the players still look the same. So what happens if the ball, if the ball's right border, so ball x plus ball width are bigger than the right inner border. Then we have to reverse the ball speed again. So these both clauses could actually be one if case as of now, but later we will likely introduce separate handling because if the ball hits the left inner border, we have to check if it's within the range of player 1, etc. So let's keep it separated because we will surely need it separated later. Then we have to define the right inner border. Right inner border. And that is, what was it? Player 2's x coordinate. So that is 560 currently. And now we can update player 2's x coordinate to use that. Right inner border. Then that is the y coordinate, which is, well, it's not important. We could technically randomly generate it within the border range, but that's not necessary for now. And then this is the width. So this is player width, and that is player height. So you see my approach to software development in general. I hope it's something it might be something you need. Many people over-engineer their software, and I like to just code very stupid stuff, stupid, simple assumptions, hard code everything, and then afterwards, when I see that something deserves more attention, I extract it to a global variable, for example. But that is a matter of taste. The end result should be the same regardless of how you do it, or similar. And as long as you get a working program, then you're fine. And especially since I'm an absolute C noob, I'm completely happy with how that's turned out so far. So we can move the rectangles. The rectangles still look the same. That means our borders are properly defined. We could technically paint them. That would be interesting, but let's forget about that. I'm sure they are properly done. And then we can move the ball. And if that works out, then we should be able to see the ball bouncing back and forth between the left and right borders. So how do we do that? We use our move rectangle function. Since the ball is just a rectangle, we pass the surface, the rectangle that we want to move, which is the ball, then the then the speed, which is the ball speed. Okay, now I'm excited. Yes, and that looks quite cool. Does the ball go too far on the left-hand side? Oh, what is that? You see the ball is punching holes into the players. Yeah. That means our border handling is not properly done. Why? I already see why. We have to check whether the x-coordinate of the ball is smaller or equal to the left inner border. If it's, because as it is right now, if the x-coordinate of the ball is equal to the left inner border, it will still move the rectangle according to the speed, which is 10, which means 10 pixels, so it will move 10 pixels into the player. And that's something we can adapt pretty simply by saying less than or equal to here and less than or equal to here. No, this needs to wait. Yeah, I almost messed up something. This needs to be bigger or equal to. Okay. Let's compile and test again. And this time, yes, the ball is properly bouncing off the inner borders. But of course, it's not really accounting for for the players. So we should check if the ball is hitting a player. And to do that, we have to introduce more handling, and that's the handling I referred to earlier, because on the left inner border here, we have to check here whether the ball position is, whether the ball is touching the player. So is the ball touching the player? Is the ball touching the upper border, or the upper end of the player? How do we do that? If the ball's y coordinate is... Okay, let me just visualize it for you. The ball's y coordinate is the top end of the ball. So we need to check whether the bottom end of the ball touches the top end of the player. Because if it does, then the ball is going to be reflected. If the ball's bottom end is going above the upper end of the player, then the ball is going into the void. And the other player will receive a point. So to do that, we have to sum up the ball's y coordinate plus the ball's height. Yeah. And we need to check if that is bigger or less than, less or equal. No, less than, because equal would be touching, because that would be then the same height. So less than, now we have to get the upper border of player 1, which would be player 1. Y. Player 1 Y. That should be it. If that is the case, then what happens then? Then technically we have to move the ball into the middle of the game again and count a score. But I would like for the game to... wait. If the ball... I would just like to focus on the reflections of the ball now. So if the ball is going to touch the player, we can do that like this. So we're checking the upper end of the ball right here. Is the ball going above the player? And now we have to check whether the ball is going below the player. So we do and the ball Y, and now we get, okay, for going below the players, imagine this is the player, this is the bottom part of the player, then the ball's Y coordinate must be smaller than the player's Y coordinate for us to be sure that they are touching. ball Y is smaller than player 1 Y. Oh, not player 1's Y, but player 1's Y plus player 1's height. Player 1 height. I'm not sure if that compiles because I left out the braces in the if statements, and yeah. Did I miss? Does it work now? Oh, it does. I was not sure if these nested if statements compile, but they do. It's interesting. Oh, that was interesting. Let's do that again. Oh, nah. So the ball is not being reflected. Why? I mean, it was... We could see that it was touching player 1. So ball Y plus ball H must be smaller than player 1 Y. No, it must be bigger than player 1 Y. Because I'm checking whether they are touching, not whether the ball is going above or below. Did I compile? No, I didn't. Oh, that looks good. That looks good. And now it's gone. Perfect. That's great. Awesome. Oh, what is that? Undefined behavior. How did that happen? Ah, the ball went behind the player 1. No. How did it get reflected off the left-hand window pane? I have no idea. Huh? Ah, now it's coming. Is it coming back now? Yes. See, now it's leaving, and when I place the rectangle on top of the ball's coordinate, the ball should be coming back. No, no idea. That is undefined behavior. We will interrupt the game at this point and just score a point. Then we also have to define well, I would like the ball to be reflected up and down according to how it touches the player. If the ball touches the player at the top end, then it should be reflected up, just like in other old-fashioned games. I'm not sure if that's the case in Pong. Wait, Pong online. Can I see how it behaves here? Oh my god, why is it so slow? I mean, it's... Hey, load. Great website. (1972) version. I want to see how the ball behaves. Wow, what the hell was that? Start game. How do I move? Ah, I move using the mouse. Okay. So I'm checking whether the ball is touching the left player, the player 1. I would need to do something similar for player 2, actually. So let's do that. So ball x coordinate. So we're checking now whether the ball is touching player 2. The ball's y coordinate plus the ball's h height coordinate are bigger than player 2 height. Player 2's height. Yeah. And then ball y must be smaller than player 2. The handling is quite similar. It's actually the same, if I'm not mistaken. So let's compile and see how that goes. Yes, the ball is exiting. Why is the ball that fast? It's way too fast. Let's reduce the movement speed a bit. Let's reduce it to 4. Still way too fast. Why? What is the ball speed? I hard-coded it to 10 here, so that is another opportunity to generalize it to movement speed. Okay. Movement speed should be 1 for now. Okay. So it's being reflected. Great. That is the perfect speed for me. And that is being reflected as well. Yes, that's nice. Yes, and that is also being reflected. And now let's just... Yes. Okay. Perfect. So that is the ball moving, and now I would like to get the ball to reflect in different directions depending on how exactly it hits the rectangle, the player 2 rectangle. So we can do, what do we do? So if the ball hits the rectangle, we set the ball speed. We invert the ball x speed, and now we have to create a y speed and set that to how exactly do we derive a reasonable y speed? It should be maybe a percentage based on the player height. So play. Where exactly does it hit the player? Do we know that? Do we know the collision coordinate? Yeah, that should be the ball y is the collision coordinate. Let's do the center of the ball. So that is ball y plus ball height divided by 2. That is the center of the ball, the center coordinate of the ball, and the center coordinate of the ball is going to be, well, if the center of the ball hits the center of the player, then nothing's going to happen. But if it hits an outer bound of the player, then it's going to be deflected or reflected in that direction. How do we do that? Here we have to do player 1 y. No, we get the center of the ball. And check how it relates to the center of the player. That might make sense. So the center of the player is player 1 y and the center of the plus player1 dot height, that divided by 2. Now we create a difference between those two. So that is whether that calculates whether the ball is above the center of the player or below, and then we divide that by the total player height. That should be it. And then after that we would have to normalize the speed, but let's still see how that behaves. I would assume that the ball will go up, for example, way too fast, and then it will exit the border. So here nothing will happen because that is player 2. We just adapted player 1. Let's see. Now it should go up. No. Does it go up? I don't think it's going up. Did I compile? Let's test again. So player 2, nothing's going to happen. Player 1. Still nothing happening. Why? Because I think is my if statement still valid? Because I left out the curly braces. Let's try that now. So this one reflects, and this one? No. Why? Ball speed X is going to be negative. Ball speed Y. I would like to log the ball speed Y. It looks like it's 0. Now I should get a log. Yes, and it's 0. Why? Still 0. So we're checking the ball's Y coordinate, which is the upper border of the ball. Then the ball's H coordinate, divide that by 2 to get the center of the ball. Center Y coordinate of the ball. And then we subtract that by the center Y coordinate of player 1. And divide that by player height R. And the issue here is that player height is 200. And if the difference of the centers of both objects is smaller than 200, then the division will not work properly. So let's just... I think we need to use doubles here. And come on now. No. Why? I mean, I'm dividing. Well, Maybe that divided by 2 thing is not good. Double. That's too slow now. I need to increase the movement speed a bit. Oh. I don't know how many doubles we need to introduce here to get a proper division. Maybe in the in this operation here as well. I know this is quite hacky, and later we might be able to do it properly. Why is this not being printed as a proper floating point number? Ball speed y. It does not like that the ball speed y is an integer. Okay, we need... I'm not happy with changing the speed x and y coordinates to doubles, because the speed should determine how many pixels we move. So I don't want to put doubles in there. So what is the issue now? Let me just create a new variable here, double y speed, and just log that. This seems to work, but the y speed is way too small to be, well, it's still going to be an integer below 1. Of course, yeah, because I effectively calculate the percentage that the center of the ball is going, the percentage position at which the ball is hitting the thing. Come on, what is the player 1? So let's just rename that to hit percentage y, and then multiply that by 100. Oh. Yeah, and that gives us a proper y coordinate. That is good. And I would like to set this to the ball speed y value. Let's not log that and compile that, and let's see if the deflection works. Well, yeah, it works, but it's way too fast. Now we should, from the percentage, we should, well, not multiply but by 100, but by the movement speed. Because that deflection rate depends on the movement speed. And then we should, then we know the, okay, that means at the topmost border of player 1, the movement speed is going to be 10, because here we're getting a fraction of between 0 and 1, and then multiply that by the movement speed, which is 10. Oh no, it's 2 right now. Nevertheless, then based off that, we should normalize the speed vector to 10, to the movement speed. So we normalize. So we do ball speed. The x speed is going to be reduced if the ball is moving up. That means we do the following. We do the x speed is still going to depend on, no, how do we normalize this now? We would need the square root here, and we would need to include math.lib. Is it that? No, math.h. Divided by square root of, does that function even exist? Square root, yes, of what? The square root of ball. We need to we don't need to make it too complicated. We can just do ball speed x multiplied by ball speed x. I'm sure there's a power function, but I am happy with that for now. And then plus ball speed y multiplied by ball speed y. That is the normalized x speed, and then the normalized y speed is going to depend on the previous y speed, but normalized. Let's see. Does not work. Undefined reference to squared. glibc. No. Forget what I just did trying to normalize this. I just had a major breakthrough event when I had a bathroom break. And it's quite simple how we can normalize the speed vector. Imagine this is player 1 and the ball is hitting up here. That is about, well, the center of the ball is about, let's say 60% plus 60% off from the center. Then we could simply And that is so simple, and I'm quite proud of that idea, and I hope it works. That is the y speed, and that is the x speed. And we could just... Is that plus 60? No, that is minus 60, because that is the upper part, and y counts from top down. And we could just then adapt the new speed vector to be 60% y and 40% x. That's it. So if previously the ball was on 100% x, now it's going to be just 60% x. No, 60% y and 40% x. So that is why it's important to find that fraction here, and I will rename that to hit fraction. That is the percentage at where the player is hit by the ball, and then we will adapt the ball speed by hit fraction multiplied by the former ball speed x. And let's do the same for the y coordinate. Let me just try whether I can do a substitute call here. X, replace it by y. Yeah, okay. And that was my idea. Let's see if it works. No, not yet. We have to declare that double hit fraction. And that is a bit... I'm not sure how well this will work out. No, I'm doing things wrongly. So the hit fraction will be a double between 0 and 1. No, between -1. What will it be? Will it be between 0 and 1 or between... -1 and 1? I think it will be between -1 and 1. And the hit fraction directly impacts the y speed, and indirectly it impacts the x speed. And the x speed should be reduced. But how exactly? I can't just... Well, my initial idea was to do hit fraction. 1 minus the hit fraction multiplied by the ball's x speed. But if the hit fraction is going to be negative, if it hits the player at the wherever, then the x speed is also going to be negative, which is not good. So the x speed should always maintain its sign. Is there an absolute function somewhere in math.h functions? Let's see what is defined there. There must be an abs. No. Returns the absolute value of x. I will use that. Come on. F apps. Okay. Let's see how that turns out in a running system. It looks like the ball's getting slower, but that is not the way I expected it to be. Why? Ball speed y is the hit fraction multiplied by ball speed y. Yeah, and if ball speed y starts off as 0, then that is not what we want. We want the hit fraction multiplied by the ball, no, by the movement speed. That went right below the ball. No, the ball needs to move somewhere. I mean, move up or down. But why does it not do that? The ball's x. Maybe my movement method is just not properly working. Let's have a look. Where is it? Move rectangle is defined here. We change the rectangle's coordinates by the speed's coordinates. So actually this is looking good. My only explanation is that the hit fraction, since it is between 0 and 1, it will be converted to an integer, which in turn I need to make the movement speed a double here. I think the integer conversion is the issue here. Okay. No. Still not the case. Ball speed x is the absolute 1 minus the hit fraction multiplied by the previous ball speed. I think I have to do that because I have to make sure that this hit fraction is also positive. And then the ball speed y. Let's log the ball speed y. Printf ball speed y is a floating point number, and we provide the ball speed y here. Why is it not working? It's because it is a digit. 0.0000. It might make sense to log the hit fraction as well. Hit frac. So the hit fraction has a value, and it is minus 46%. Why is this not working? Am I stupid? The movement speed is 2. That is fine. So if we calculate hit fraction multiplied by the movement speed, it should get a value of 1. But that is not the case. Why? The hit fraction is a double anyways. Maybe this will work. These are just desperate attempts to get something working. No, it does not move up. Why is the ball speed Y? Huh? Why is the ball speed not being updated here? What if I use a bigger speed so that the multiplication is more likely to happen? Yeah, super. That is super testable. No, that's not the way. That's not the proper way to do it. Ball speed Y. What if I just say ball speed Y is equal to 2 right here? Will it move up? Will the ball move up? If yes, then the issue is our calculation. It will move down. Okay. So the issue is really this calculation. So we're getting the hit fraction, which is the what is the hit fraction? What is the hit fraction if I hit the ball at a very high place, such as, no, bad example. Here it is 0. Here it is 0 as well. And here the hit fraction is close to 0. Why is it close to 0? That means the hit fraction counts down from the bottom of the, oh my god, of the player rectangle. So the hit fraction is the center of the ball. Ball y plus ball height. And that is subtracted by player 1 y plus player 1 height. That is do we have to divide player height by 2 maybe? Ooh, that could be it. Let's see. Okay, that is movement 0 in y direction, and if I do that, then it should go, yeah, that's not good. So the ball speed is reversed here, the ball x speed. Then a hit fraction is calculated. Then the ball speed x let's not adapt the ball speed x for now. This will make the movement a bit unrealistic, but I think it's better for testing. So now it should go down. Does it go down? No. Now it should go up. Oh, that's good. Yeah, the problem is that the up and down movement will only... No. I think because the movement speed is currently 2, the ball speed y can only have the value 0, 1, or 2, and that's not very good actually. So I'm thinking of how to solve that. I would like to give it a more fine-grained angle at which to move. But to do that, we might have to update the y coordinate of the ball only every second frame. Now we're updating it every frame. This is not as easy as one might think in the beginning. Okay, but let's leave it like that. I think it's still quite nice. The movement is quite... Now the way you could expect Pong to behave. And let's do the same handling for player 2. So this should be the same piece, the same block of code as for player 1. The only difference is that here we have to replace player 1 with player 2. So we do that. Player 1, player 2, global. Let's see if that works. Oh, yeah. Okay, now the ball moves out of the border. So I would like to implement a collision detection for the borders as well. And to do that, I will do if ball y is bigger than or equal to 0. The upper border is always 0. Then we'll reverse. No, then we'll reverse the speed, the y speed of the ball. And if the bottom part of the ball touches the lower border, then we reverse the y speed again. So if ball y is, oh no, here I have to do smaller than 0 because that would be go into negative space. If ball y is bigger than, ball y plus ball height is bigger than or equal to, and now we need to get the bottom dimension of the surface or the window. And where do we code that? The window size is 640 by 480. And this is, I think, time to put into another global variable that is the bottom inner border. That is 640, and we might as well also make a top inner border, which is 0. Although that I don't find that quite as necessary, but let's just follow through. And now we need to. Wow, I'm losing where I left off. Okay, here. So here I have to check the top inner border, reverse the ball speed, and here I can use the bottom inner border. And reverse the ball speed again. Then we will use these new global variables in the for initializing the ball in the middle of the screen. So to do that, we do a left inner border plus right inner border and divide that by 2. I really enjoy these kinds of things. I can't believe it. Many people really, they condemn programming or don't really enjoy it, but I love that kind of stuff. Especially because 1 month ago, or maybe even just a couple of weeks ago, I had no idea about C. I really had, I knew a few basic syntax things like incrementing and decrementing and coding a main method with a hello world, but that's it. And now we're coding a Pong clone. So this is really, I love that. I think these are the right things to spend your time with, or at least they are a good waste of time. Let's put it like that. And here we can use the middle of that, of the wait. So bottom inner border plus top inner border divided by 2. And then the ball size is, for that I will create a new variable, ball diameter. Okay, the ball diameter is 20. Ball diameter is 20. Let's compile. For sure it will have an error. No, it works. This looks good. This looks good. And it bounces off the border. That's great. That's awesome. Actually, that's already a working game almost. Now we just have to, do we just have to count scores? That's quite nice. I'm really happy with that result. Oh my god. That's awesome. I will stop the video at this point. I really think this is a good close for an episode. If you enjoyed it so far, leave a like and subscribe, and make sure to tune in for the next episode. In the next episode, we will count scores, and I guess then we might have to reset the screen when the game finishes, and that's it then. Wow, so cool. Awesome. Let's see what happens when I let the ball exit the screen. Nothing, it just vanishes. Yeah. So then we have to interrupt the game loop or reset and count scores for the individual players. But this is awesome so far. I love it. Okay, see you next time. Bye.